what would be the stereochemical classification of the major product of this reaction? Okay, right, so here's some options. First, we have to determine the product of this reaction, so let's do that. Okay, so for this reaction, right, this is from chapter 6, this is an addition reaction. So first, right, we have an acid, HBr, right, so we want to look for nucleophiles and electrophiles. Right here, double bond has electron density, that's our nucleophile. Here we have an acid, right, so what's going to happen, right, this is a strong acid, so immediately when it gets in solution, it donates its proton, right? And so once we do that, right, this acts as an acid, we go from here to, I'll just redraw this, H plus, Br minus, right? So this also has a lot of electron density, so that's also a nucleophile. This guy is just a proton, so it is an electrophile, right? It's electron loving. Okay, so nucleophiles attack electrophiles, right? So these, the pi bond goes and forms a bond with the H. So what are we going to get? Here, we'd get, let's redraw this, CH3. We had a C, we have an H. We broke this double bond, right? C, we have a CH3 and a CH3. Okay, so, right, we formed a bond to an H here, right? So we could either do one of two things, right? We could either put an H there, and if we did that, we'd have a carbocation here. Or we could add that H over here, right? And that would put a carbocation here. So, remember, carbocation stability is tertiary is more stable than secondary, which is more stable than primary. Right? So let's determine these carbocations, right? This carbon is bonded to two other carbons, so it is secondary. Okay? This carbon is bonded to 1, 2, 3 other carbons, so it is tertiary. Right? So we'd like to keep the tertiary carbon is most stable. So this intermediate right here is the most stable, right? So it will, when this forms in solution, it can stay there long enough through stability and move on to the next step. Okay? So now we have, let's see, let's erase this. Now we have this guy here, tertiary carbocation intermediate. And what do we have left? We got rid of this guy. We have Br minus hanging around, right? A nucleophile. We now have an electrophilic carbon. Carbocation is electrophile. This is our nucleophile, right? Nucleophiles attack electrophiles, so that's going to go there. So we can draw up our product. We had CH3, CH2 now. Then we have C that was bonded to two methyls. And we added a bromine to this guy. Now, okay, in this compound, do we have any stereocenters, right? Well, this carbon's bonded to 3 H's. This carbon's bonded to 2 H's. This carbon is bonded to 2 methyl groups, right? So there's no carbon that is attached to, that is bonded to 4 different groups, right? That's what we need for a stereocenter. So every carbon in this molecule has at least 2 of the same substituents attached to it, right? So that makes this carbon achiral, right? There's no chiral centers in this compound, okay?